So we're going to do an example problem. This is going to be a redox reaction. We're going to complete and balance this reaction in an acidic environment. So this is going to be a demonstration. So let's write down what we're going to do. So we're going to complete and balance the redox reaction, assuming an acidic environment. Okay, so here is our reaction. This is what we're going to be working with. So we have sulfite and permanganate. And that is going to sulfate and manganese dioxide. Okay, so that's our overall reaction. So what I want to do here is go through the steps to balancing this reaction in an acidic solution. So step one, we have to separate this guy into half reactions. Okay, and we also need to balance the non-hydrogen and non-oxygen atoms. So we're going to do that later. So that's going to give us sulfur and manganese that we need to balance. So let's do that step first. So let's separate them into half reactions. So I'm going to take the sulfite, I'm going to keep it on this side, and I'm going to put an arrow, and then I'm going to leave some space. So that's why things are spread out a little bit. That's on purpose, because we're going to do some more to this. So there is our sulfur-related half reaction. So let's go ahead and do the same thing with the permanganase going to the manganese dioxide. Okay, so we have separated out the two reactions, and let's look at it, and we see that the sulfurs are balanced in the first reaction, and the manganese atoms are also balanced in the second reaction. So what we're going to do next, this is step two. So in step two, what we're going to do is add water to each half reaction. And that's going to balance the oxygen atoms. So that's the goal of this. That's why we're adding water. So let's look at the first reaction, and we see that we have one less oxygen on the left side of the reaction. So I'm going to go ahead and add a mole of water to that side. And that balances oxygen atoms in the first reaction. We have 4 oxygen atoms on each side. So now we want to go down to the manganese reaction, the half reaction, and we're going to look, and we see permanganate has, on the left side, has 4 oxygen atoms, and the manganese dioxide only has 2. So we need to add 2 moles of water to that half reaction. So now step 3. We're going to add H plus, because we're in acidic solution, to balance the H atoms in each half reaction. Okay, so now we have added water, so that has actually introduced hydrogen into our equation. We have to balance that. So I'm going to add 2 moles of H plus to the right side of the equation in the product side in the sulfur half reaction. And in the manganese one, I am going to look here, and we have 4 hydrogen atoms in the products. And so I need to add 4 H plus to the left side of the reaction. So those balance out. Okay, so now we have to balance electrons. So this is step 4. We have to balance electrons. So we need to add them to each side in order to balance the charges. Okay, so let's look at what we have charge-wise in the first reaction. So we have the sulfite, the sulfate, those two have the same charge, but notice we've added 2 positive charges to the right side of the equation, the reaction side. And so we need to add electrons to balance that out so that we basically have 2 minus on both sides of this equation. So I'm going to add 2 electrons here. Okay. Now let's look at the manganese reaction and do the same thing. So we have 4 H plus, and then we have the negative charge here. And then if we look on the product side of the equation, we have 0 charge. So it's neutral over there, no charge. So we have to get to that point on the left side of the reaction. So we already have 1 negative charge, so that cancels out one of those positive charges from the protons, or the H plus, but we still need 3 more electrons in order to totally balance those charges. Okay, now what I'm going to do is actually rewrite this on the next screen so I can show you what we're going to do next, because what we need to do is balance out those electrons so that they cancel when we add these 2 reactions together. Okay, so let me go ahead and rewrite what we have, and then we will go through that process. All right, so this is what we had. Okay, so we're gonna go to sulfate plus the 2 H plus the 2 electrons. So that's our first half reaction. Second half reaction is going to be our 3 electrons plus our 4 H plus permanganate. And that is going to go to the manganese dioxide and the 2 water. All right, so we notice that we have 2 electrons in the first half reaction and 3 electrons in the second one, and that obviously is not going to cancel out. So what we need to do is multiply each of these half reactions by a factor so that we get the same number of electrons on both sides of the equation so they cancel out. So what we can do with that is we can multiply the first reaction by 3, and that's going to give us 6 electrons, you know, and then of course we have to change the coefficients for everything else, which we will do in a second. If we multiply the second reaction by 2 times 3, that's going to give us 6 electrons. So we've found the factors that we need. So now what we need to do is go through and multiply. So I'm going to rewrite this. So we're going to have 3 H2O and 3 sulfite. That's going to go to 3 sulfate, and 3 times 2 is 6H plus and 6 electrons. Okay, for the second one, we're going to have our 6 electrons. We're going to have 8 H plus 2 permanganate. That's going to give us 2 manganese dioxide and 4 water. Okay, So I'm going to go ahead and just check myself really fast, make sure that I did this properly. And you should always do the same thing because sometimes it's easy to write down the wrong thing. All right, so looks pretty good. Okay, so now what I want you to do is basically think about the process of canceling all of this out. So we're going to go through and we're going to find everything in common, and we're going to add these two reactions together. So let me go ahead and put a line here because we're adding them all together. But first, we want to cancel out anything that is found on both sides of the equation. So on the same side of the arrow. So let's start with our electrons because that's actually easy because we multiplied by the coefficients necessary to get rid of our electrons. We have 6 on each side of the equation, and so they cancel out. Another place that we can cancel is with the waters. So we have 3 waters on the left side of the equation, and we have 4 waters on the right side. So we can actually cancel out that 4, and then we just end up with 1 of them. Okay. Now let's do the same thing with the H+. We get rid of all of our H+ in the product side, and we end up getting rid of the vast majority of them on the reactant side. So we end up with 2 H+. So now let's go ahead and write our final reaction out. We're going to end up with 3 sulfite and 2 manganese permanganate. And don't forget our 2 H+. And we're going to end up with 2 manganese dioxide and a water. So now we have balanced the redox reaction in acidic solution, and we have canceled out all of our electrons. And so this is our final reaction. And actually, though, I forgot one more thing. So that's why you should always check yourself. Okay. So now we have all of our products. Yes. And so now we have our final reaction. So definitely email if you have questions on this. But I would suggest trying another one, balancing an acidic solution right after this so that or trying this very problem by yourself without the video to make sure that you have the process down.